Hi, welcome to my video on explaining how an ellipse is formed if the sum of the distances from a point to each focus is constant. Okay, let's start our video. I'm going to lay a board down to do this. So there it is. So what I have, I'm going to set up the vertices of an ellipse. So the vertices are going to be at 5, 0 and a negative 5, 0. And the vertices, oops, sorry, didn't mean to put the blue pen for the vertices. And I'm going to put the foci at negative 4, 0 and 4, 0. So, as we did before, if we take the, pretend that the foci, instead of being at 4, are at negative 5, and the foci are at 5. That means when we take a string and move it through like this, put a string down and haul on it, the distance from the between the vertices and the foci is the same. So what we get in this case, we get a straight line. We did that in the previous video. That means we have no ellipse. Okay, let's move the string. Let's take our foci away now. There's the vertices at negative 5 and 5. What about if our vertices stayed at negative 5 and 5 and we moved our foci to negative 4 and 4. So this is negative 4, 0 and 4, 0. So now let's run a string now between these. Okay, trying to get it set up to see if we can explain it. Here we go. So there's the foci. Instead of being at 5, negative 5, 0 and 5, 0, they're now at negative 4, 0, 4, 0. So that's the foci. Now we'll draw ellipse. Remember, the vertices are 5, 0, negative 5, 0. The distance here is 10. The distance here is 8. That means I'm able to draw an ellipse. So going through 5. There it is. Drawing the ellipse, making sure this is solid and not moving. Okay. Kind of gone through negative 5. There it is. So, again, the vertices were at 5 and negative 5. You can see foci are at 4 and negative 4. There's the ellipse. And just to show you that, notice that this is oval in shape. Now, again, just to mention that the distance from here to here is 2a. So A is 5. The C's are 8 units apart. So the C is 4. 4 units from center to here. 4 units. So the eccentricity, which is E, eccentricity is the C over the A. So the eccentricity is the 4 over 5. So the eccentricity is 0.8. So it's if the two foci, if the foci and the vertices were the same, we would get just a line. But now we have 0.8, so we're getting an oval shape. Okay, based on that, I'm going to move these clips now, pins I should say, and the line. So what happens if I take this point right here And we take another point. Let's take another point, any point on the, wherever you want. Let's take this point right here. So I'm going to, if you look at the distance, if you measure the distance from this point to each of the foci. So let's draw each of the foci. So this point to here, and this point to the other foci of -4. There it is there. So if I measured this distance from this point to this foci and this point to this foci, let's see what we get. That's about an 8. And this is roughly 2. So it was 8 plus 2. So that means that let's call this F1 and let's call this one F2. So PF1 plus PF2 is 8 plus 2, which is 10. Let's take another point. Let's take this point and to the vertices. So here we go. So to the foci, sorry. So let's draw this one. And let's draw this one. So now let's call this point by another name. Let's call it H, just not to get confused. So HF1, and on HF2, let's see what HF1 is. HF1 is 5. HF2 is 5. So 5 plus 5 makes 10. So notice any point, if you take any point on this ellipse, the distance from the point to the two foci will be 10. Notice the vertices are at 5 and -5. That distance is 10. So that means that the H, if we take, let's take P to be any point. Let's take P to be any point. Let's say, not this P here, but let's take this point. So any point, no matter where I put the point, if I take the point here and draw the lines to vertices, that distance is, we mark it, any point to foci 1 plus the point to foci 2, we add the distance together, we will always get a 10. But notice that the distance between the vertices, so that's 5 here, and that's 5. So PF, so the vertices, if you take the vertices and the vertices V2, V1, if you want to call them that, V2, the distance between the vertices is 10. So that means that's the vertices, the distance between the vertices is an A, because this is A from here to here, this is A from here to here. So if that's an A, then that's a 2A. So that means 2A is 10. So that means A is 5, which makes sense, 5 and 5. So that means that any point on the parabola, any point on the ellipse, I don't know where I got the parabola there, any point on the ellipse, the sum of the distance to the foci is always 2A. And I want to mention also, notice this is the length of this axis here is 10. That's the major axis because it's longer. Notice that the length of this one is, just see it, this is, if you think about it, in this triangle, let's look at, we mark out this triangle right here. This is triangle. So I'm looking at this triangle right here. H, O is center 0, 0, and 4, 0. Notice this distance here is 4. This distance here, that's 1, 2, 3, that's a 3. And if this distance is 10, that means this is 5 and 5. Why? Because these two triangles are congruent. This is a perpendicular, and this is 4 and 4, being coming down here, perpendicular to this F1, F2, makes it a right triangle. These two triangles are congruent. So HF1 is equal to HF2. So since that distance is 10, they're 5 and 5. And the Pythagorean says that 4 squared plus 3 squared is 5 squared. Okay, that's one example. Let me do another example with another board. Here we go. I'm going to put another board down. And I made up these boards to explain what's happening. But this time I want to spread, I want to get out to the full length. Okay, there it is, full length. Now I'm going to deal with the vertices are at, I'm going to make vertex 1 and vertex 2. So the vertex is negative 10, 0. And it's, this vertex over here is 10, 0. So if I put the blue for the vertices, let's put one right there, and put another one over, oh, a bit of wool there, another one here, make sure I got that lined up so you can see it. There's the two vertices, 10, 0, 10, 0, and negative 10, 0. So let's put the foci. Again, if I put the two foci into place on top of the vertices, then the distance, which is A here, A, this is 10 and 10, so A is 10, A is negative 10, the distance here for the vertices is 20. The foci are the same distance, so if you think about it, again, the foci, the eccentricity is the C over the A, and they're both 10 over 10, so we get a 1. So that means if I put a string around these right here and come back here, I would get a line. But let's take this one away and this one away, and notice my vertices are negative 10 and 10. But now I'm going to take the, instead of the foci being at negative 10 and 10, put the foci at negative 8 and 8. So I move the foci in. Instead of being at 10 and negative 10, I move them at 8. So now the string, the distance, remember the distance from a point on the ellipse to each of the foci, it's got to be the same. So let's see what this distance is going to be. So I have the making sure everything's okay before I draw it. Here we go. Stretch it out, and let's see what we're going to get. Go right around. Again, notice we're getting, oh, keep coming. Got it drawn. So take these away, take the line away, and so notice now I have the ellipse. Notice that this is 6, negative 6, hitting right at a point. This is 8. So what happens is that if you take any point you want, so let's take this point right here. remember now, the foci, we have the foci at -8 and 0. So I'm going to put the foci in red just to show you that the foci. So the foci are at -8, 0, and 8, 0. So these are the foci. So this is F1, F2. So if I draw a line from the point P to the foci, so let's draw this line here, or line segment I should say. A line keeps going on forever, but a segment stops. So that's one segment. And to the other foci, PF1 is, let's say it's okay, ruler's almost not long enough, but we should manage. So what is the distance of this point? So if I take the point P, if P, let's make it PF1 and PF2, let's see what the distance adds up to be. PF1. Now I need to get a longer ruler. If I don't, a longer one to measure it, because if I don't, it won't. So I have this is in, okay, there we go, 15.5. Oh, 16, right on, 16. So PF1 is 16, and PF2, let's see what PF2 is. PF2 is 4. So that adds up to 20. If we take this point, let's take this special point right here. Let's take this one and join them up and see what we get. So why am I picking this special point? Because this point right here, if this is the longest axis, the major axis, this is the minor axis. So the horizontal axis is major because it's longer, because it's 20. And this is the minor axis, which is 6, and 6 makes 12. So the vertical axis in this ellipse is the minor. So if I go to the foci, PF1 to PF2, let's see what we're going to get. Okay, so this is a special one. And what do I mean by that? Well, it's special because this distance here is 10. So this distance PF1 and PF2, so it adds up to 20. So this distance right here should be, oh, move that away, and I have 10. And that means, let's see what the other one is going to be. Again, this point forms a pair of, again, 10. So why is this point special? This is right on the end points of the minor axis. So this is 10 and 10, so that's 20 altogether. So if you call this point H, so that means HF1 plus HF2 is 10 plus 10. Notice they're equal, giving you the 20. So this is 8 from, this is 8 here. And this is 6 here. And we got a right triangle because the axes are perpendicular. And notice that 6 squared is 36, 8 squared is 64, that's 100. So this length is 10. It's measured to be 10, but it's Pythagorean property. 6 squared plus 8 squared is 10 squared. So this distance, this point is special because this point is at the end points at the minor, which is forms the two congruent triangles, so it splits the distance of, again, the vertices are 20. These distances from the point to the foci is 20. So this makes it 10 and 10. And as a result, we have any point. Take any point on the curve. Take this point. Take this point. Take this point. You take any point on the curve, no matter where it is. That means that P F1 plus P F2 in this case is 20 long, but the 20, the vertices, the V1 to V2 is 20. And 2A is 20, so A is 10. So if you got 10 and 10, that makes it 20 here. But for any point, in this case, you have a 20, but the 20 is the 2A, so PF1 plus PF2 is 2A. In any ellipse, any point on the ellipse, from the point on this ellipse, or on any ellipse, the point PF1 plus PF2 is always 2A, which is the distance between the foci. And therefore half of that is, if you set up this triangle, you will get an isosceles triangle. And let's explain that a little bit more. Let's go back and put that, just go back to another sheet now. Trying to explain to make sure we know what we're doing. Okay, here we go. Now, if you take this line and I put a vertex here and a vertex here, and there's two vertices, and these are the two foci, F1, F2. This is the center, 0, 0. So this, between the foci, we have negative C and C. Between the vertices, we have negative A and A. And so this distance here is between the vertices is 2A, between the foci is 2C. And so what happens when you set up draw your ellipse will go like this. I'm just taking a rough guess now. Don't have to be exact. Just trying to make it oval. So one thing we have to do, that your foci and the vertices are on the major axis. So if this is, because the vertices here and here, the horizontal axis is the major. So when I draw this one, which is perpendicular down through here, this one is the minor one. But because we have foci, so if you take any point, let's take this special point, let's take this one. So that means that P F1 plus PF2, PF1 plus PF2 is equal to the distance between the vertices, which is 2A. And that means that the vertices, if you think about it, the vertices are at plus or minus A, and the foci are at plus or minus C. Again, the center is 0, 0. Now, another one, since this is 2A here, this is an A, and this is an A, because this is this triangle, P, F2 to the 0, and P, F1 to the 0. These two triangles here are congruent with this right angle. Now, this is a C here, and this distance here is the B. So A is on the, A goes with the X, and B goes with the Y. So this is a C, which is distance between foci. This is the distance of the co-vertex. These are the vertices. These are the co-vertices right here and here. So this distance is B. So we have, this is an A, which is half the distance between the vertices. So that's a 2A. So that's an A and A because of equal triangles. So what we have is that we have that A squared by A squared, which is, this is the HY. I got to write this down. Hypotenuse squared is leg 1 squared plus leg 2 squared. Now I have to use hypotenuse is the sum of the squares of the legs, because I didn't want to use, notice the C, A, and B are going to get mixed up. So A squared is the hypotenuse, B squared plus C squared are the two legs, because normally C squared equals A squared plus B squared when C is the hypotenuse, but A is the hypotenuse this time. So that means that C squared is A squared minus B squared. So in any ellipse, the distance from of the foci is always the half the major axis, which is the A squared minus the B squared. So in any ellipse, C squared, which is the distance of the foci, is the distance of the vertices, split in half, square, and the distance of the minor axis cut in half. So C squared is A squared plus B squared. Again, C is the foci distance, A is half the vertice distance, and B is half the minor axis distance. And still, eccentricity is still the C over the A as a ratio. So whatever this distance is here, divided by this distance from the center to here. So if this is a 20, this is a 10. If this is an 8, so it's a C over A, which is 8 over 10, or 4/5. So just wanted to make sure to explain about the foci. In order to, the foci sometimes makes it confusing, and what happens, trying to make it help you understand. And if you, again, if you wish, if you like my video, click on the like button. If you're not subscribe to my channel. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.